To demonstrate the clustering example, we leverage one of the most simplest and popular datasets available within the Python ecosystem. So sklearn provides a couple of datasets ready to use under datasets. Let's import that. So we say from sklearn import datasets. That looks good. Now we'll import the dataset iris. So iris is a dataset which is widely used for a classification use case. It provides 4 descriptive features about the flowers, the sepal length, sepal width, petal length, and petal width, and gives you a class of the flower. Now let's have a look at the data by loading it. So we'll say datasets dot load iris. Now by default, you won't get the data in a data frame format. We need to convert that. So let's typecast it by saying iris underscore df is equal to pd dot data frame. Data is equal to, let's put numpy, import numpy as np. Now we'll create a combined data set. So we have the target variable separate within this iris object, and we have the attribute separate. So we'll combine them using the numpy's concatenate operator. So we'll say np.c underscore, and we'll provide a list of data sets we need to combine. So we'll first combine iris data attribute. The second one would be iris target. Now this would be 4 columns, and this would be the 5th column. Let's go ahead and pass on the column names. So this would complete the numpy concatenation. So we'll pass on the column names. So columns is equal to iris feature names. Now this is a list of column names, but we don't have a name for the target variable. So we just append that and we'll say target, and that completes. Let's create this data frame. Now if you have a look at this data frame, let's say we say check the type just to be double sure. We say iris dot underscore df. Yeah, that's a data frame, and we say iris dot shape. We have 150 rows and 5 columns. Let's look at the number of different columns we have. So we have sepal length, sepal width, petal length, and petal width, and we have the target variable. Now the target variable will be a label encoded version. So let's say iris underscore df head, and we'll see 5 elements. Here we go. We can clearly see we have the dimensions in centimeters and the target as a label encoded version. If you just check and we double check, you say iris target unique, and we have the unique values in this column. So it's iris underscore df, my bad. Then we have 0, 1, and 2. Now for this clustering exercise, we won't be leveraging the values from the target column. And if you want to understand what are these target columns, target values referring to, you can just refer to the original iris dataset and you say target names. You get the names corresponding to each of them. So we have Sentosa corresponding to 0, Setusa, Versicolor corresponding to 1, and Virginica corresponding to 2. My bad, sorry for the pronunciation. So let's ignore this for now, and let's create a simple data set which we can use for the clustering exercise. So we'll be implementing the k-means clustering algorithm. So if you look at the data set, we have the data sets on different values. Just to simplify the data set's distance measuring process, we can convert all of these values with the standard scaler. So sklearn also provides a standard scaler module. So we say from sklearn.preprocessing import standard scaler. Now after we import it, we need to convert them in the variables. So we'll say x is equal to first we'll create a standard scaler object. So we'll say std is equal to standard scaler. We'll initiate that, and then we'll say x, which will be our training data set, is equal to std.fit_transform, and we'll pass in the values which we have from the above dataset. That will be iris underscore df dot values, and we'll pass all the values except the last column. We'll say all the columns, all the rows, and all the columns except the last one. So we just execute this. You can see we have 4 columns and all rows. Now if you pass this under standard scalar, it will first fit the object and then transform these values and store them into x. Now x will have standardized values. There you go. Now let's pass this newly transformed data set into the clustering algorithm. So for clustering, let's import the clustering function. So from sklearn dot cluster import k-means. We create a k-means object in our lowercase is equal to k-means, and we will run the algorithm with a couple of extra parameters. We can pass, but we forgot one thing to add. We forgot to add the number of clusters over here. So this attribute is required to be pre-calculated. Now we are providing 3 just as a random number. We're not really sure about. So if you look at the actual target variable, we understand there are 3 distinct classes, but then not in every scenario you'll have this luxury. Assume that in a scenario where you don't really have any idea about how many groups to get started with, there are different techniques which will help you to understand the ideal number of clusters that are possible within this data set. So one of those techniques is the elbow curve. We'll get into the details later, but for now, we'll just create 3 clusters and we'll instantiate this object. So k-means is now an object defined with the parameter 3 clusters. Now we'll say k-means dot fit. Now we pass in the x values over here. So the values which you have created earlier, we'll just pass in over here and we create the fit function for this cluster. Now, instead of using the predict function, you can just say k-means dot classes labels. We'll have the cluster values. So it's not classes, it's labels. Now, the usual process like we do in linear regression would be we'll fit the data and then we'll do a predict function and see the values. Now, in this scenario, since we have passed on the entire data set, we can just pass on the values and see what are the values corresponding to each of the data points we have in X. We can alternatively do the other way also. Let's say if you want to understand something like k-means, I'll just clear this mess. So k-means dot predict, and we pass x over here. If I run this, we'll have the same value. So what will happen over here is k-means has now created a fit function and it has understood the structure of data. When you pass x, it will predict and transform that structure onto x and give you the outcomes in terms of labels. So we have 3 clusters, so we have labels 1, 2, and 0 over here. Now, in reality, you won't have the luxury to go and compare these labels with the actual labels. But then we can actually do a comparison over here since we actually have the target labels. But we'll keep that for the next section where we'll evaluate machine learning algorithms. So that was a basic introduction to clustering, and we just looked into a simple example to explore how we can implement clustering algorithms k-means in Python. I'll let you explore how to implement a hierarchical clustering example within Python.